Thank you all. Good morning. It's an honor and a pleasure for me to be here. My name is Diogo Castro, and I came from CERN here to present you SWAN, our Jupyter-based interactive data analysis service. And given that this is the first time that CERN is present here at JupyterCon, we decided that it was important to give a broader presentation, and so I'd like to give you some context of what CERN is, what it's doing, and how Jupyter is helping us do what we do. And then I'd like to present you SWAN, how we integrated, explain you how we integrated Jupyter with our infrastructure, what were the challenges, what we did to personalize it, and lastly, I'd like to go through the future and think about the next steps for our platform. But let's start with the context and explain you what CERN is. CERN is a physics laboratory. It was founded in 1954, and it's focused on research, technology, education, all of these in the domain of fundamental physics. And probably when I mentioned the words, the word CERN, you thought about this. We are home to the largest and the most powerful particle accelerator in the world. It's called the Large Hadron Collider, or LHC for short. And it's a ring with 27 kilometers, or almost 17 miles. And why is it useful? It's useful because it is helping us discover more about the basic building blocks of matter and the forces that govern our universe. And it was thanks to it that we discovered the Higgs boson. And like it, CERN has many other accomplishments in physics. But what I'd like to tell you today is that we not only have accomplishments in physics. A lot of innovation that comes out of CERN spans multiple areas. And one that I thought is interesting for this audience, and actually it was mentioned this morning, is the invention of web. Sir Tim Berners-Lee was working at CERN when he invented the web, and it's something that now makes Jupyter possible. And like him before, we are a community nowadays of almost 18,000 people working at CERN or collaborating with CERN. Out of these 18,000, almost 13,000 are international collaborations. But more than speaking about numbers, it's important also to mention where they are coming from, which countries take part in this massive experiment. And as you can see, almost all countries in the world take part with us in the pursuit of new discoveries. And one community very important to us at CERN is the HEP community, or High Energy Physics community. And this is how they work. This is their pipeline. To give you some context, we at the LHC, we have 4 main experiments. They are called ATLAS, ALICE, CMS, and LHCb. And these experiments produce something around 1 petabyte of raw data per second. But not all of this data is relevant, and it's such a large amount of data that only a few of this data is really stored, because we do event filtering right out of the detectors, both by hardware and software. And only then we store this data in our storage system, which is called EOS. I will mention a bit about it later. And then it goes through all this pipeline. It gets reconstructed. It's stored in what we call root files. I also going to mention what root is in a bit. It gets processed, skimmed, and in the end, we have what we call analysis datasets. So these are much smaller datasets, so small that many of our users download them into their own computers and perform the analysis in there. And as you can see and imagine, the last process of the pipeline is the analysis itself. And it's an interactive process, and usually the result is a plot or a graphic. This is something about the future, a challenge that we have, but I decided to mention it right away. The LHC is already at its limits, but we are now building an upgrade to it, which is called high luminosity. And this upgrade means that we are producing much more collisions in the detectors, and it also means that because we are also improving the resolution of the detectors, we are getting more data, and the plan that the information that we have is that almost 13 times more data will be produced at these experiments. And as you can imagine, this is a lot of data. And because it's so much, our tools need to get improved, and we need to face new challenges to be able to cope with so much data. And for example, I mentioned that many of our researchers download their data set into their computers. Maybe they won't be doing that anymore because it won't fit. So we need to provide tools that will allow them to analyze their data, and SWAN is one of the tools that we think can help. And I'd like to present you now SWAN, but before, I'd like to tell you how it came to be. And I already mentioned this name before, and there's a physics data analysis framework at CERN. It was built by us, and it's called Root. And this is no normal tool, because this is the tool that is used by all physicists around the world. And it has libraries for whatever you might imagine. It's a very powerful tool, and it's span across all this pipeline of physics research. As you mentioned, we store our files in root formats because we provide such a powerful and optimized libraries for I/O. There are many other libraries, but one that might interest this audience is the analysis library that we have. And basically, what happened was that the root team was thinking, how can we provide an easier way to access this tool? How can our researchers do their analysis in an easier way? And so they thought, let's try to make this available as a web service. They looked for tools to integrate with it, and they found Jupyter. They decided to integrate Jupyter in root, and vice versa. And what happened was that the first C++ kernel that was created to Jupyter was born. So now you have other kernels for C++, but the first one came from the root team. And when the team did this, when they did this integration, they realized maybe we can provide this as a service for our users. So that's what they did 3 years ago, and they created SWAN exactly for doing that. And this is what SWAN is. SWAN is a service that provides access on demand to notebooks. So it's still powerful. You still have access to the root framework for analysis, but this time you don't need to install it, you don't need to configure, because everything is available as a web service. And since Jupyter is such a powerful tool to provide easily shareable scientific results, of course, SWAN is also a tool for doing the exact same thing, because we are integrating Jupyter. But as you can imagine, we needed to provide a service that met our researchers' needs, so we had to integrate a lot of other tools for them to access their software, their data, and of course all the power that they need to perform their analysis. And although this started as a root side project, we also integrate with other analysis ecosystems. In our case, the ones that matter to physics, to the HAP community. Getting back to the pipeline, I said that the last step is an interactive step, and as you can imagine, this is the perfect fit for Jupyter, and is actually where it's being used by your community. So they are performing the analysis step with the help of SWAN and Jupyter. These are the three pillars of the service. Of course, if we wanted to provide access to software and storage to data, we had to make some choices. We looked around for tools to integrate in the service, and what we realized was that we had so much powerful tools in-house developed at CERN that were the tools already being used by our community, so there was not a real choice here. These had to be the tools integrated in the service. And I like to say that SWAN is an integrator, not only because it integrates all of these services across multiple departments, but because it's also integrating teams at CERN. And actually, the storage team is one of the team that took part in the project since the beginning with us. And from these three pillars, you don't know two of them, storage and software. So I'd like to present them to you. Just a last note here, all of these tools are open source. So these are our contribution to the community. So if you want, you might be able to use it in your own deployments. But let's start with storage. I mentioned that in CERN, all this data is stored in what we call EOS, is our disk storage system. So we decided to integrate it in SWAN, and by doing so, all of experiments data is already available to the users once they start their sessions with Jupyter. And one good thing of EOS is that it also provides a user space. So if you have a CERN account, you have a space where you can store all of your files, usually work-related files. And there's a service called CERNBox, which allows you to access this storage space. And it's more or less like Dropbox, okay? But it's the one developed at CERN. And it allows you to sync all of these files across devices. So you can imagine you can start doing your analysis locally in your computer and then continue in SWAN. Everything is synced. You don't have to think much about it. And it also provides a very interesting functionality that is sharing. Of course, collaborative analysis is very important in our community. Sorry, just a sec. And then there's software. Again, we have a tool at CERN called CVMFS. This is a read-only distributed system that we use to distribute software across all of our equipments, across our grid, the worldwide grid that we have. And inside this system, we have what we call LCG releases. What an LCG release is basically a package where you put some software libraries with specific versions, and we install them, or the team that builds this system installs them. And they guarantee that all of these packages are compatible with each other. So when you select an LCG release, when you're starting your session, you get all of these hundreds of packages that come along. These are the packages that our researchers are using. So by doing so, we already gave all the software that they need without having to think much about it. And this also allowed us to reduce the Docker images that we use, because we are using Docker for our users. And you can imagine that hundreds of packages will produce gigantic Docker images, but we don't need to do it because they come from this service. And it's important to mention that this is a lazy service. So if you need only package A and B, you only get package A and B, even though the stack has hundreds of packages. But of course, we have a lot of caching mechanisms to guarantee that this works well. And so by doing this, we are providing almost all the packages that our researchers need, but we have multiple users, power users, that need personalization. They need other packages that are not available. So, of course, we provide a way for them to install these packages. they can configure all of their environments. When they install these software packages, they get installed inside CERNBox, so you even get this sync automatically for you. So you still can personalize all of this environment to your needs. And a note here, we are providing 4 kernels to our users, Python in version 2 or 3, depending on the stack that you choose. We have also root C++, of course. This was the origin of this project. Then we have R and Octave. All of these come from CVMFS because that's where we install them. This is the architecture of the service, just so that you know that we are using Jupyter Hub and we are using Docker to start user sessions. And of course, we need to integrate with the authentication service at CERN. Everything needs to be behind our SSO for security reasons. And we provide all of this access to the infrastructure that I already mentioned. And so we provided the service like this. We put Jupyter on top of the infrastructure. But then, of course, we thought we can go further and we can provide more functionality to our users. And so we started by providing a new interface to them. And we put on top a couple of extensions to give more functionalities. And we have all kinds of extensions. We have NB extensions, server extensions, and even kernel extensions. This is how it looks like. So in Jupyter Hub, the menu that you can, where you need to start your session, you can select the software stack. So the CVMFS LCG release that I mentioned, you choose it here. You can also provide a startup script, so you can do whatever you like to your session before Jupyter starts. And there are other options, of course, but one interesting is that our users didn't like to have to do multiple clicks, so we provided them an easy way for them to start automatically with the default configuration or the previous selected configuration, so that's what the little checkbox in the end is. Again, how it looks like. So if you're familiar with Jupyter, you will recognize this. But all of this personalization had a purpose. As I mentioned, collaborative analysis is very important at CERN. No one works alone. So they constantly need to share their work with a supervisor, with a colleague, with someone outside of CERN. And so it was very important for us, the sharing functionality. And so we decided to bring it inside the Jupyter interface. And now the users don't need to go and switch between CERNBox and SWAN because they can share right from within the interface. And when we did this, we thought, usually, users share their notebooks, of course, but they also share input data. They can share some pictures, whatever they need for the project. And so we decided to create what we call a project. And a project is more or less like it's a special kind of folder, let's say like this, and it should be self-contained. And this is the single unit of sharing that you can share from SWAN. So when you share something from SWAN, it needs to be inside a project. It's a simple way of looking at this, and it simplifies the process for our researchers. And of course, when you share something with someone, you can see what others share with you. You can even open the shared projects and look inside, look what files are there. You can see notebooks in read-only mode. And the idea here is that you know what is inside so that you can decide, does this make sense to me? Can I work with this, or do I need to work with this? And this is because we provide users the ability to clone projects into their own user space. So what they do is that they get a copy of this project inside their own CERNBox, and we do this for a simple reason. Currently, Jupyter doesn't allow concurrent editing, so it's much safer for us to provide this functionality through a cloning mechanism than by sharing the folder with two people at the same time. And again, once we provided this, our users liked it. Yes? Sorry.
Are you waiting for questions at the end?
Yes, yes. Okay. So we provided these new functionalities, and of course our users wanted more. In particular, department at CERN, which is the BIMS department, they are the ones that build the LHC, and they are the ones that today operate this machine. And what they do is that they collect logging information from all the devices across LHC. And this is an interesting case because we're no longer talking about physics data, the physics data that come out of the LHC, but all of these logs that come out of the machine. And they decided to adopt Spark to process all of this data, but they were missing a unified platform to do the analysis. And so they came to us, they asked us if we could provide such a platform, and so we decided to integrate Spark inside SWAN. So now you can access the CERN cluster that we have right from within SWAN. And a very important thing here is that thanks to EOS and thanks to CVMFS, you have the exact same environment both locally and in the cluster. So if you are working in your notebook, you can try it locally, and you know that it will run in the Spark cluster because it's the exact same environment, even though these are completely decoupled. But as you can imagine, usually these jobs take a long time to finish, to produce results, and this defeats the purpose of interactivity. So we had to provide some tools that would give the users this interactivity that is common with Jupyter. And so we developed two extensions for this. The first one is the Spark connector. So you just need to click a button and you can configure all of your connection. You can set all of the properties that you need for Spark. You hit connect, you get some animation with the logs that are coming out of the cluster, and then you are connected. You are ready to go. We export this into the notebook. We export Spark into the notebook, and so you can start writing your analysis without doing anything else. And when you do so, when you write your analysis and you submit the analysis to the cluster, you get this. This is a monitoring tool that appears automatically below the cell that you run, and it allows you to see all the progress bars for the jobs that were created. And you can even see the task timeline, and you can see the resources that we are using. And this last one is very important because by looking into this, you can see if you are taking advantage or not of all the resources that were allocated to you. And an interesting thing of this is that this became, it started as a Google Summer of Code project. At CERN, we are an umbrella organization of GSOC, and this is one of the many successful projects that we have each year. So successful, actually, that we decided to create something similar this year. And so we thought about providing access to our batch servers. We have what we call the WLCG. This is the Worldwide LHC Computing Grid. It's a worldwide grid that gives enormous amounts of storage and processing power. And our users are used to submit jobs here. So it made perfect sense that we allowed them to submit their jobs from SWAN, just like they submit jobs to Spark. And so this year, again, as a GSOC project, we started building the integration of batch inside the Jupyter interface, and we did the same thing as Spark, and we created some monitoring tools for you to see what is happening in the background. And if you look again at the pipeline that I already showed you, you can imagine that with this new high luminosity LHC, it will be very important for us to provide access to these enormous resources, because they will need them to provide the analysis that they do. But it also means that we can go a bit back in the pipeline and use SWAN for the processing stage that we have, the stage where the researchers produce the analysis data sets. Another thing that I would like to talk is education. It's part of CERN's mission, education. And we have a lot of programs each year. We just had, in the last 3 months, our summer students. We have them every year at CERN. But we also have tutorials all year, both at CERN and spread across the world. We have a lot of PhD students that work at CERN. And as you can imagine, Jupyter is such a powerful tool for this that we decided to adopt Jupyter extensively for these activities. And we're even going a bit further, and we have an European project, European-funded project that is called Up to University. And the idea of this project is to bridge the gap between higher education and university. So we aim to bring the tools that we provide to researchers and to university students back to higher education, for the students to start learning with those tools. And when I say SWAN, it's the full SWAN. So all the software packages that the researchers have access to, EO, CVMFS, everything comes along. Just a brief mention about our users. We have around 200 daily users. It more or less doubled since we deployed the new interface. We're also seeing growing numbers with when we start deploying Spark, which was a couple of months ago. And we also see an enormous increase in the usage when we have courses and tutorials. Many times we don't even know that someone planned a tutorial that uses SWAN, but when we look at the numbers, we understand what is happening. And our community is very important to us, because it's this community that is helping us shape what SWAN is. I mentioned the example of the BEAMS department, but there are others, and they usually come to us, they ask us for functionality, we work with them to integrate these functionalities inside SWAN, and in the end we have the habit of creating notebooks that exemplify how you can use these functionalities. So if you go to cern.ch/SWAN, you can see almost 50 notebooks that exemplify how to use SWAN, and most of them related to physics. But let's look ahead, and this is what we're planning to do with the platform. The first thing is to move to Jupyter Lab. As you can imagine, many of our users need more powerful tools than what the traditional notebook can provide, and we think this will be a way to attract these users that don't see SWAN as a useful tool for them. And of course, this means that we will have to port all of our extensions, but it's part of the job, right? Then, of course, we also want to investigate a new architecture for the service. We are studying the adoption of Kubernetes. We're also studying the usage of GPUs, because the HAB community is now looking more and more to machine learning, and we need to provide them GPUs, because these are what brings some speed to their analysis. And lastly, I already mentioned this, we are moving ahead with LHC, we are bringing the new high luminosity, and this brings a lot of new challenges that we need to solve, and I think SWAN is getting ready for them. If you want to find us, these are our contacts, our email, our website. Most of our code is public, not all of it as of today, but we are working to make this available. And we also have what we call ScienceBox. This is what we use in that European project called Up to You. So we containerize all of our services, and you can access and deploy them using Kubernetes or Docker Compose in your own infrastructure or in your own computer to try it. But just a heads up here, all of these new interface and functionalities, they are still not there. So this is a bit behind our production environment. We are working to bring them into this containerized version, hopefully in the next months. Just to finish, what I think you should take from this presentation is that we did a lot of integration with Jupyter. We are really providing Jupyter notebooks on top of our infrastructure, and by doing so, we are boosting the productivity of some of our researchers, and we're giving them access to disk, sync, storage, software, everything without the need of configuration and installation. I also want you to remember that Jupyter is very important for us in education. We have a lot of programs and we use it extensively. And something that summarizes all of this is that Jupyter is becoming an entry point for all of these massive resources that CERN has. So they have other entry points as of today, but SWAN is becoming a very important entry point for these. And lastly, of course, there are things that we need improvements, and one of it is to provide more powerful tools, and we think that Jupyter Lab might help. And so this ends my presentation. I think we still have time for some questions. I hope you're not bored to death. Thank you. Yeah. So root is mainly C++, but it has automatic bindings with Python. So you can also do your analysis in Python using root. And that's how we integrate it. The kernel uses Python to connect to root.
And you just made those available as APIs within the library that, for example, that this could be used to functionality.
Yes.
The second question, you mentioned that you have multiple users that I could use my own version of the notebook, or you could develop something, I can develop something, and we can collaboratively do it, but not at the same time.
Yeah.
So how is that? Is there any kind of merging that can take place, or anything, any way to combine?
As of today, it's a very simple service. So you share it, you clone it, and if you want to get back to the original owner, you need to share it again. So for now, we don't have any other way of doing things. Okay.
So where's the Jupyter running? If the user types, doesn't bash command, what computer is it running?
It's running inside the kernel. Sorry, it's running inside Docker container that we spawn. We have machines dedicated to SWAN. So they provide the compute power to.
Your users are not used to doing bash commands directly on the user.
I'm not sure, but what I imagine is that they submit these batch jobs into the grid into the grid. There they can submit and do whatever they like. And actually, yes, we have what we call LX Plus. It's a you can do. It's a terminal. You can do whatever you like, and it also provides computing power.
So your users are used to going through Spark to do their job.
This is something new, Spark. So they are not used to use Spark. They are starting to use it now, but yes, they can use the command line to submit Spark jobs, and they use this LX Plus that I mentioned. But now they're migrating into SWAN because it's simpler for them to use.
So for our users, they use SWAN, but they're used to using, like, typing direct commands into the supercomputer shell. So you have to be running over in the supercomputer. So I was just wondering, have you looked? I guess there are issues with running Jupyter on the supercomputer, actually hosting it.
In our case, we do this because it's our service, it's our machines. We know, we configure them, so we control this environment. If they want to use Jupyter, they can still use Jupyter, but not SWAN. SWAN is the service that we provide. Yes. They have that in the batch service, yes, and that's what we integrated into SWAN. You submit your job and it gets scheduled, yes. Sorry, I assume so. I'm not an expert in this batch system, but I assume they can do it, yes. Everything that is produced in these batch jobs, it's written into EOS, so you can just look at the logs that are produced there. And actually, that's a way users get their results. They look into the files created in EOS to see the results. And we're trying to bridge this gap and make them available right in SWAN, in the notebook. Yes? So basically now what we have with Kubernetes is this Dockerized, this version that we have, this ScienceBox version. And yes, we have, it's a way of spawning user sessions. We have containers for each of these components, and we have, you can create, for example, in our pilot for up to you have 2 machines where you can start your session. This is how it is today, but we are still investigating what we should do next. Something that we thought was to deploy only the kernel itself in externally and access it, but it's still not set in stone as of today. Yes.
So since you're maintaining Jupyter Hub, I'm sure there are cases where it's not big Jupyter Hub and your Jupyter servers might lose connection to Jupyter Hub. Like, in preparing for these scenarios, do you have some kind of monitoring tools that you guys use, or you have alerts set up? How do you let your users know that there might be a maintenance happening?
Okay, so as you can imagine, CERN has massive resources. So of course we provide centrally logging systems centrally. IT provides this for us. So every machine that we run, we have an orchestration system, which is Puppet, and we deploy these services using Puppet. And by doing so, all of this functionality comes along because it's mandatory for services that run at CERN. So that's how we get all of this information. And of course, we have a system where you can set maintenance schedules, everything. So it's a ticketing service. So when our users create a ticket because something is not working, there is someone that will redirect them and show them this is downtime, this was programmed, so everything is fine. You just need to use something else. So, yeah, maybe that.
You don't look at, there
Yes, that's actually, we had a visit of a person from Jupyter team. They came to CERN, and that was the first question that she made me. Don't you use Git for this? And the answer is no. And actually, many of our users don't even know what Git is. And also, we don't have any tool that allows them to do this in an easy way. Of course, they can use it. Jupyter provides a terminal, so they can, of course, use it to do it, but we don't provide a graphical way of doing it. But that's one of the features that we are looking, and that's why I say that Jupyter Lab provides such a more powerful environment, because all of these tools are coming along, and it enriches all of the experience for the users. Yes.
Quick question about you. So if I understand correctly, you said you can run the notebook as part of the hosted environment or on one of the scientists' local machines, and you use Fuse behind the scenes, if I'm understanding correctly. Maybe I missed something. Sorry, so for the CERNFS.
CVMFS, yeah.
Looks like it's the connection to that is Fuse-based. So if the scientist was running the same notebook locally, they could potentially set up a Fuse connection on their system to talk to the data center. I would imagine you've got a wide variety of machines, Linux, Mac, Windows. How do you help the users through that process of getting?
So when the librarians install these packages, they install for different environments. And when you want to use CVMFS to load all of these packages, you need to source a file that installs and configures all the environment, right? And if you choose the correct system, you get all the packages that were installed for that system. But actually, I'm not sure that we provide that for Windows. But you have many options of Linux environments. Yeah. So the resources that we provide to each user, it's actually an option that we have in the startup menu. So they can choose between 8 and 10 gigs of memory, and a couple of processor number of cores options from 2 to 8, I think. So in the end, if they need a more powerful environment, they use the grid, and that's why we want to integrate it with SWAN, because we don't have resources to provide them all of this power in our service, and they already exist, so we just give them access to these resources, and that's it. Okay, and it's probably out of time. Yeah. So thank you so much.